Hi. Now we are going for the quick revision from the chapter Quadratic Equation. First question. Which one is the quadratic equation? We know that the general form of a quadratic equation is ax square plus bx plus c is equal to 0. Four equations are given. We have to find out which one is the in the form of a quadratic equation. Consider first equation. 5 by x minus 3 is equal to x square. At first look, we feel it's a quadratic equation. But before concluding that, we have to simplify this equation. 5 by x minus 3 is equal to x square implies 5 minus 3x. Take the denominator x, 3x equal to x cube. 5 minus 3x is equal to x cube. That implies if we rearrange again it, x cube plus 3x minus 5 is equal to 0. X cube plus 3x minus 5 is equal to 0. This is not in the form of ax square plus bx plus c is equal to 0. Because the highest power of the variable x is 3. That means this equation is not a quadratic equation. Consider the second one. X into x plus 5 equal to 2. First, remove this bracket. For that, multiply it. X into x, x square plus 5x equal to 2, or we can write it as x square plus 5x minus 2 equal to 0. X square plus 5x minus 2 is equal to 0. This is in the form of ax square plus bx plus c is equal to 0. Here the variable x and its highest power is 2. That means this equation is a quadratic equation. Consider the remaining equations also. N minus 1 equal to 2n. Here the highest power of the variable n is 1. So we can say that this equation is also not a quadratic equation. Then consider the last equation. 1 by x square into x plus 2 equal to x. How we can rearrange this equation? X plus 2 equal to x into x square. X into x square. We multiply this x square in the denominator to the right hand side. That is x into x square. X into x square equal to x cube. X plus 2 equal to x cube, or we can rewrite it as x cube minus x minus 2 is equal to 0. Here also the highest power of the variable x is 3. So we can conclude, we can say that this equation is not a quadratic equation. From the given equations, x into x plus 5 equal to 2, we can rearrange it as x square plus 5x minus 2. This equation is a quadratic equation. The answer is B. This one is a quadratic equation from the given set of equations. Second question. Out of the following equation, which one is not a quadratic equation? Consider first one. X square plus 4x is equal to 11 plus x square. How we can rearrange this equation? X square plus 4x minus 11 minus x square equal to 0. Move the terms from the right hand side to the left hand side. X square plus 4x minus 11 minus x square is equal to 0. X square minus x square. How we can write this equation again? 4x minus 11 equal to 0. Plus x square and minus x square. X square minus x square is 0. So the remaining terms are 4x minus 11. The highest power of the highest power of the variable is 1. That means it is not a quadratic equation. X square equal to 4x, or we can write it as x square minus 4x is equal to 0. Here the highest power of the variable x is 2 and its coefficient not equal to 0. That means the term x square exists in this equation. So this is a quadratic equation. P is a quadratic equation. Consider next one, 5x square equal to 90. This is also we can written as 5x square minus 90 equal to 0. Here also the highest power of the variable x is 2 and its coefficient is 5. That means coefficient not equal to 0. So we can say that this is also a quadratic equation. Consider this one, 2x minus x square equal to x square plus 5. Here sometimes we have a tendency to cancel these two x square, but this is minus x square, and if we rearrange this equation, it's become 2x minus x square, and the terms on the right hand side become minus x square minus 5 equal to 0. We can simplify it again as 2x minus x square become minus 2x square minus 5 equal to 0. 2x square minus 2x plus 5 is equal to 0. Here the variable x has the highest power 2 and its coefficient not equal to 0. So we can say that this is also a quadratic equation. That means from the given equations, equation number A is not a quadratic equation. Out of the following equations, equation A is not a quadratic equation. Consider question number 3. The roots of x square plus kx plus k is equal to 0 are real and equal. Find k. Options, the given options are 0, 4, 0 or 4 and 2. Find which option is correct. The given quadratic equation is x square plus kx plus k equal to 0 and its roots are real and equal. For a quadratic equation, its roots are real and equal means the value of discriminant, that is b square minus 4ac equal to 0. The value of the discriminant is 0. Consider now find out the value of b square minus 4ac. The coefficients, write down the coefficients. A, for this quadratic equation, a is 1, b equal to k, and c equal to k. Then b square minus 4ac is bk, that is k square minus 4 into a is 1 and c is k. 4 into 1 into k equal to 0. That implies k square minus 4 into 1 into k is 4k equal to 0. Or we can write it as k into k minus 4. From the two terms, take k as common. So we can write k into k minus 4 equal to 0. The product of two terms 0 means either one of the term is 0 or two terms may be 0. So equate each term to 0. K into k minus 4 is equal to 0 implies k equal to 0 or k minus 4 equal to 0. K minus 4 is equal to 0 means k equal to 4. That means the value of k is equal to 0 or k equal to 4. From the given options, option C, 0 or 4 are the value of k, either 0 or 4. Answer is option C. Fourth question. For root 2 x square minus 5x plus root 2 is equal to 0. Find the value of the discriminant. Given options are minus 5, 17, root 2, 2 root 2 minus 5. Find the value of discriminant. Discriminant d equal to b square minus 4ac. Okay. Write down the coefficients. A equal to root 2, b equal to minus 5 and c equal to root 2. These are the coefficients. Find the value of b square minus 4ac. b is minus 5. Minus 5 square minus 4 into a is root 2 into c is root 2. Root 2. Minus 5 square is, square of 5 is 25. Minus 5 square is 25. 25 minus 4 into root 2 into root 2. Root 2 into root 2 is 2. 4 into 2 is 8. 25 minus 8 equal to 17. For this given quadratic equation, the value of the discriminant is 17. From the given options, option B is the correct one. The value of the discriminant is 17. Fifth question. Which of the following quadratic equation has roots 3, 5? 4 quadratic equations are given. We have to find out these roots are the roots of which quadratic equation. If we are trying to solve this quadratic equation, we get its roots, but it's time consuming. But we know that if the roots of a quadratic equation are given, using that roots we can form the its corresponding quadratic equation. How? Form the quadratic equation as x square minus sum of roots into x plus product of roots equal to 0. Using this relation, we can form a quadratic equation if its roots are given. Here sum of roots. Sum of roots is 3 plus 5. 3 plus 5 is 8, and product of roots. Product of roots equal to 3 into 5 is 15. So using this, how we can form its quadratic equation? X square minus sum of roots 8x plus product of roots is 15 equal to 0. Using the given roots 3 and 5, we form its corresponding quadratic equation x square minus 8x plus 15. Here the option B, x square minus 8x plus 15 is equal to 0. That is, for the quadratic equation x square minus 8x plus 15 is equal to 0 has the roots 3 and 5. So our answer is option B. Sixth question. Out of the following equations, find the equation having the sum of its roots minus 5. 4 quadratic equations are given. 3x square minus 15x plus 3 is equal to 0. X square minus 5x plus 3 is equal to 0. X square plus 3x minus 5 is equal to 0. And 3x square plus 15x plus 3 equal to 0. Our question is, the which quadratic equation has its sum of its roots is minus 5. We know the relation x square minus sum of roots into x plus product of roots equal to 0. If roots are given or sum of roots and product of roots are given, we can form its corresponding quadratic equation using the relation x square minus sum of roots into x plus product of roots is equal to 0. That means the coefficient of x is sum of roots. Here sum of roots given that minus 5. If we go through these equations, the equation option B, x square minus 5x plus 3 is equal to 0. Here the coefficient of x is 5. But sum of its roots is minus 5. That means minus of minus 5. Our required coefficient is plus 5. That means the coefficient of, if the coefficient of x is plus 5, then we can conclude that for that quadratic equation, its sum of roots is minus 5. But here the coefficient of x is minus 5. The quadratic equation A, that is 3x square minus 15x. Here it's the coefficient of x is 50. So we can drop this option. And for option C, the coefficient of x is 3. So we can drop this option also. And option D, 3x square plus 15x plus 3 is equal to 0. We can write this quadratic equation as x square plus 5x plus 3 equal to 0. Or we can simply write as x square plus 5x plus 3 is equal to 0. If we divide this equation on both sides by 3, we can write it as x square plus 5x plus 3 is equal to 0. In the same way, the option A, 3x square minus 15x plus 3. Here we can take 3 as common. Then the option number A becomes 3 into x square minus 5x plus 1 equal to 0, or x square minus 5x plus 1 equal to 0. This is option A and this is option D. Here the coefficient of x is but minus 5. But in the case of option D, here the coefficient of x is plus 5. If the coefficient of x is plus 5, we can conclude that for that quadratic equation, its sum of roots is minus 5. That means from the given option, option D is our answer. 7th question. Root 5m square minus root 5m plus root 5 is equal to 0. Which of the following statement is true for this given equation? Real and unequal roots. Option B, real and equal roots. Option C, roots are not real. Option D, 3 roots. To find the nature of roots of a quadratic equation, we have to find the value of discriminant. Depends on the value of discriminant, we decide its nature of roots. So find the value of discriminant. Value of discriminant is b square minus 4ac. Here for the given quadratic equation, b is a is equal to root 5, b is equal to minus root 5 and c is equal to root 5. Root 5. B square is minus root 5 square minus 4 into a is root 5 and c is root 5. Minus root 5 square. Minus root 5 square of root 5 is 5. Minus become positive. That is minus root 5 square is 5 minus 4 into root 5 into root 5. Root 5 into root 5 is 5. 4 into 5 is 20. 5 minus 20 equal to minus 50. Here the value of the discriminant, that is b square minus 4ac, is a negative value. If the value of the discriminant is negative or less than 0, means the roots are not real. From the given options, option C, roots are not real. Our answer is option C. Question number 8. One of the roots of equation x square plus mx minus 5 is equal to 0 is 2. Find the value of m. 4 options are given. The given quadratic equation is x square plus mx minus 5 is equal to 0 and 2 is its one root. 2 is one root means at the point 2, this quadratic equation becomes 0. That means P of 2 equal to 0. P of 2 is equal to 0. P of 2 is, in the place of x, substitute the value, substitute 2. That means this quadratic equation become 2 square plus m into 2 minus 5 equal to 0. Therefore, we can write it as 2 square is, therefore P of 2 is equal to 2 square is 4 plus 2m minus 5 is equal to 0. That implies 4 plus 2m minus 5. That is 2m minus 1 equal to 0. That is 2m is equal to 1. Therefore, m equal to 1 by 2. The value of m is 1 by 2. From the given option, option C. Our answer is option C.